going to continue from where we left off with numerical summaries. And we're going to be essentially looking at, oh, I better put the section in just in case for notes you want to remember where you are. We're still in chapter 2. And we're looking at the numerical summaries. And in particular, we're still going to be focusing right now on a specific group of numbers called the 5-figure summary. And so I want you to imagine that, and I'm just going to pick my own set of data, that you collected some data and I'm putting it in order. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Right. So there were 11 data points. And let's suppose this happens to be the ages of people in a chess club, right? So there's a local community and there's a chess club there, and these are the ages of the people. And we are going to create what's called the 5-figure summary, and we're going to do it by hand. And then we're going to show you questions where you can use software, and you can also use the TI-85 to do the same job. So I'm going to show you different ways in which to get the same result, right? The same 5-figure summary. And there might be small differences in Q1 and Q3, and that's caused by the fact that calculators are not human beings, and the way they do them is sometimes just a little bit different, but not significantly so. So a 5-figure summary consists of these 5 numbers: the minimum, a guy called Q1, first quartile, a guy called the median, which actually in some textbooks is called Q2, a guy called Q3, and finally a guy called the maximum. Well, once the data is in order, which is a biggie, that guy is your minimum and that guy is your maximum. And weren't they called the extremes? Was another name for it. 11 and 70. Now, once you've got those two, the next guy you get, if you're going to do it by hand, is the median, the middle number when they're in order. Now, there are 11 numbers here. So if you think about when it's an odd number and there's 11 or 13 or 21, and you want to know where to stop, where the middle number is, add 1 to that and half it, and you get 6. So I know guy number 6 is the middle. 1, 2, 3, 4, 5, 6. It's you. But just to be sure, 1, 2, 3, 4, 5, 6. It's still you. Do you see in that case, the same guy in the middle, you don't have an issue, right? The median is 23. So far, so good. Right, now, all we have to do now is show you how you can calculate Q1 and Q3 by hand. And as I did say a few moments ago, we will do this again using our TI-84 and show you that, excuse me, sometimes there might be a little bit of difference with these, and that's okay if that happens. What you imagine happening is there. Do you see that the median 23 has split the data into 2 pieces? You got the little guys on the left and the big guys on the right. Now, when the median is a single number, I want you to imagine that you built the wall right in the top of it, right? And so what I've got left here are 5 numbers on this side. Do you see them? And Q1 is essentially the middle of those guys. Would you agree it's number 14 then? See it, the middle? So this guy here is Q1. And there are 5 numbers over here, and this guy is called Q3. So we have a 14 and we have a 31. And we have now created our 5-figure summary.
So, sir, I got a question for you about that.
Yes.
So would it follow the same rule? For example, if there was 6 numbers per
It'd be
se.
halfway between 2 guys, yes.
Yeah, so you just add them and divide them again?
Yeah.
Okay.
Yeah. Now, the thing about calculators are that they're not clever enough to do that. So the calculator will have its own little process, and it might say, for instance, that that's 13.75 or that's 30.5 or something. And I'm just saying, don't worry about it. It's just the way calculators work, and we can't do anything. Maybe in the future they'll have cleverer calculators. Now, I am going to now use this to do one of those box plots. I have a problem. Whenever you create box plots, and that is, we need to worry about outliers. Now, I'm looking at the ages of these people, and I'm pretty sure that 11-year-old is not an outlier. Would you agree that 11-year-old's pretty close to everybody else? What I'm really worried about is that 70. Couldn't that easily be an outlier? Exceptionally large compared to the rest of the data. Now, to be able to calculate the outliers, we first have to find a guy called the interquartile range. And he has the formula that it's Q3 take away Q1. In this case, that's 31 take away 14. And I believe that comes out to be 17. You okay about the interquartile range? We did that yesterday. Now we create an upper fence and a lower fence. Since I'm not really worried about that 11, I'm 99.9% sure it's not a problem. I'm only going to calculate the upper fence. And the upper fence is a number that says, if you're bigger than this guy, you're an outlier. And the upper fence is Q3 take away, add, I should say, 1.5 times the interquartile range. So Q3 is 31, add 1.5 times 17. And I don't have... has somebody got a calculator handy? It saves me having to jump around with my screens here. Just tell me what 1.5 times 17 is.
25.5.
Okay. So our upper fence is 56.5. Okay. Now, if you are a data point, in this case an age, and you're bigger than that number, you're an outlier. Oh, doesn't that make 70 an outlier? Now, how's that going to affect my box plot? Well, it means that I'm not going to use that guy in my picture. He's going to be a little asterisk. And I'm making a kind of decision here how that's going to work. I know I need 10, I know I need 7. So 10, 20, 30, 40, 50, 60, 70. Don't really need 80, so I won't do it in. And I'm going to put a little asterisk, a little star thing for that guy. Now, my minimum is 11, which is there. My Q1 is 14, which is about here. My Q3 is 23, which is about here. And my Q3 is 31, which is about here. So I'll join those guys together. And that guy there. And I don't draw my line to here, because that's an outlier. What I do is I join it to the next guy. So do you see that this is my box plot with a little outlier? Now, the other choice I would have, and now that I've seen this, I might have went with it. Wouldn't I not even bother with that 70 and just do a bigger picture of that, and then right underneath, star 70 as an outlier? Just physically tell people, because that does look a bit crunched, doesn't it? And it's a bit hard to see what the numbers are. Are we good? That's how you deal with it. Now, I'm going to now jump over and do the same data set, and we're going to do a 5-figure summary and see what the differences are, if any. So you hit the start button and you choose number 1, which is edit, and then you type in your numbers. So here goes. I have 11, then I do 13, then I do 14, then I do 17, 21, 23, next one's 27, then we have a 29, then a 31, 40, and finally a 70. Are you comfortable with that? Start, edit, put in your data. So start, choice 1, edit, put in your data. Then you do start, move from edit to calc by pushing this button once. Choice number 1, press enter. In my case, L1 is there, so I just hit enter, enter, enter. And let's see where the 5-figure summaries are. The minimum is 11. Q1 is 14. Median, 23. Q3, 31. And last but not least, 70. Wasn't that a perfect match? And that's good. But I just warned you that there might have been a little difference, because sometimes you get a 30.5 instead of a 30, and just live with that, right, when it happens. Looking good? Any questions then about, if I give you a set of data, do you feel comfortable enough that you could create a 5-figure summary, check for any outliers, and then draw a box plot? That's pretty much it. I got a lot of nods on that, so I'm happy. So I have no idea what you're looking at right now. Are you looking at question 5 right now?
Yes, sir.
Okay, so in question 5 homework, do you see that you've got a lot of stuff to do? Here's your data set. I would very strongly suggest, wouldn't that be a good candidate for the TI-84? Right, just type the numbers in and let the TI-84, take the string. If you had to do that by hand, wouldn't you have to rewrite these as a big long list from smallest to biggest? Right, I mean, it could be done, but I think it'd be quite long, right? And you're trying to be efficient with your time. Now, here is another data set. And these are the cholesterol levels of 20 individuals. And here is our 5-figure summary. And here is our choice of pictures. And we are going to use some software, which is even more efficient than the calculator. Because in the calculator, you have to type in all the numbers. When you use software, it already knows what the numbers are. You just need to know where to get the answer that you're looking for. Right? So this might not work with Zoom. In other words, I may have to do some switcheroos, but let's find out. I'm hitting use salt. Oh, good. It looks like it's working. Are you looking at a thing that says salt and it's blue and there's a lot of numbers? Okay. So what I want to get here is my 5-figure summary. Agreed? So I'm going to go and hit descriptive statistics. Now, do you see what I've hit? Descriptive statistics. Now, what you'll get is more than you want. So you have to know what bits you want and ignore the rest. Since I'm interested in the 5-figure summary, can you see that the only numbers I'm interested in are those 5? That makes sense? So Minimum 144, the median 181, the maximum's 226. Everybody's happy, right? Now, if you want to foot about with it, if you uncheck things, can you see you can just make it only show what you wanted? I mean, to me, it doesn't seem worth it, but for some of you, yeah, there are too many numbers, I end up writing the wrong one down. Just go over here and uncheck everything except the 5 numbers in your 5-figure summary. And that means the only guys you will see are the 5 numbers that you want to see. Now, you could use that to draw your own box plot, but we should be able to use SALT. So I'm going to go charts and graphs this time. And do you see the guy called box plots? Now, here's a little idiosyncrasy. We typically do our box plots horizontally, and WebAssign likes to do them vertically. If you ever look at them in a textbook, horizontal is just as often as common as vertical, right? So it's not a big deal. So I'm going to hit this one, and I'm going to select a variable, which is cholesterol. And hey, I might have to shrink this down a little bit. But can you see the box plot on its side? Now, if you turn your head on its side, actually this way around, you should then be able to go back to the original question. Can I go back to the original question? There's a question on itself. Yes, here we go. One of these 4 pictures on its horizontal side, right, would be the same as the guy that we've got. Now, I'm not sure. I'm going to go back and look. The median is 181. Do you see that guy there, 181? Maybe that's enough to tell the difference between them all. Okay, so it's definitely not that one, because isn't the median miles away from 181? Let's do it by shapy boxes. Big, small, small, big, big, small. Let's see if that makes any difference. It goes big on the left, then small. Okay, so big on the left, then small. So my best guess, it's that one or it's that one, right? So the only thing I would probably choose then is maybe what the value of Q1 is, and that should decide it for me. If I got my picture and I've lost it. Anyway, can you imagine it's not as hard as doing it. It's hard for me jumping back and forward. But if you've got the damn thing in front of you, can't you then just look at your answers and say, it looks like C? And that's what you do, you pick C. Now, in question 7, this is the weights of people who are on a rowing team. Now, there are different kinds of rowing team. This particular one, I don't know if you've seen it, say, in the Olympics. It's one of those things you see like once a year. They have like 8 or 9 guys and a little guy at the front, and he shouts on one of those old-fashioned megaphones, 1, 2, 1, 2. Do you know the kind of guy I'm talking about? He's called the coxswain, if you're interested. Now, he doesn't do anything, or she doesn't do anything, except keep people in rhythm, right? 1, 2, 1, 2. So they row in synchronous. So if you are going to take part in a competition, and weight is important, don't you want that person to be very slight and slim? So let's go for the last question first. If you scan through this data set, which one of those people would probably be the coxswain, right? The guy who shouts, or the girl who shouts. I would make the assumption that it's the lightest person in the group, right? And so when you go down here, you pick the lightest person in the group. That makes sense? Now, in this question, it's use SALT 5-figure summary. And then it has a question B, identify whether or not any data points would qualify as an outlier. So that really means I have to do some work. if I was looking at this data set and I was just eyeballing it, aren't the outliers at the extreme ends? Somebody who's really, really small or somebody who's really, really heavy. So if I was going to make a prediction, couldn't that person be an outlier? Now, if I scan the data, because they might have it, do they have some really, really heavy, muscly person? Well, the biggest person I can find is what, 195, right? So they could be an outlier as well, couldn't they? But I can't do it as a judgment call. Yes.
Wouldn't it be 213?
Oh, yes. Even higher, right? So it could be the 213 person, right? But I can make a judgment call. Don't we have to do that upper fence, lower fence thing? Which means there's a fair amount of work to answering that question. So let's hit use salt. And I'll do this as a little question. Which one of these choices at the top do you use to get the 5-figure summary? Which one of these on the top do I pick to get the 5-figure summary?
Charts and graphs, maybe?
That's what we use to draw the box plots or to get a picture of the box plots. Last chance.
Descriptive statistics.
There you go.
Right.
It's there. And why don't we rub out all the things that don't matter again? Now, can you see our 5-figure summary is good to go? See them there? Now, I'm going to write these guys down because I'm wanting to know, are there any outliers, right? And so I'm going to write these guys down. So I've got a minimum, which was the Coxswain of 108.5. And then I have a Q1, 181.5. We have a median, 186.5. We have a Q3, 199.75. And finally, we have a max of 213, which is the one that you picked, James, right? The 213 guy, the heaviest.
Yes, sir.
Right, so let's see which one of those two, maybe this one and this one, maybe only this one, maybe only that one. Well, whatever I do, the first thing I'm going to calculate is the interquartile range, which is really ugly because Q3 take away Q1 were not very pretty numbers. They're 199.75, take away 181.5. So I know it's going to be a 0.25, and I believe it's going to be an 8. Goodness gracious. What's that going to be?
18.25.
Thank you. 18.25. Now, let's check each one singularly. Let's go for the very light person. So we're going to get what's called the lower fence. And the formula for the lower fence is Q1 take away 1.5 interquartile ranges. So it's going to be 181.5 take away 1.5 times 18.25. I definitely need help. What's that guy times that guy going to get us? It's about 30-ish is a very basic guess.
$27.375.
We got a nod on that, I'll use it. Yeah.
What's that, sir?
No, I'm just asking if we're getting a verification. Okay. Now, if you take these one away from the other, you're left with 100 and what?
54.125.
Okay, now, is that person smaller than this? Yes, that person is an outlier. Okay, let's go for the 213. You know, the heaviest guy on the boat. Well, he will be an upper fence. And the formula for an upper fence is not the same as that, but similar looking. Instead of subtract, you add. Instead of a Q1, you use Q3. So this time it's going to be 199.75. And these two guys, we've already found what they are, but we're going to add them this time. And what do you get when you add this and this together? Certainly in the 200s, but 200 and what?
227.125.
Okay, so now we ask ourselves the same question. Is this one bigger than the upper fence? And the answer is no. So doesn't this make this guy totally safe? He is not an outlier. Are we cool with that process then, right? The 5-figure summary, we use it to get the interquartile range. We then find the lower fence and find out if you are smaller than the lower, you're an outlier. We then get the upper fence, and if you are bigger, which in this case you're not, then you're not an outlier. So that when we go and return back to our question in the homework, we will be looking at, I think, only one outlier. Identify whether or not any data points would qualify to be marked as an outlier on the box plot. If their outliers, specify their value. Well, their value was 108.5. Now, that's all there was, but can we just pretend for a minute that the other guy was also an outlier? You would write it down with a comma. Can you imagine there might be a situation where there were two outliers and they both were outliers because they were extremely big, right? You don't just necessarily get one big outlier. Couldn't you have two or even three or none? You know, the rule is if you're bigger than the upper fence, you're an outlier on the big side. If you're smaller than the lower fence, you're an outlier on the small side.
So
How we do? Yes.
on that, sir, and I don't even know that it really matters, but where does the 1.5 come when you're calculating the upper and lower fences?
This was a kind of number that statisticians just decided on.
Okay.
They just said, hey, we're going to have to pick something. From your experience, excuse me, what number tends to generate answers that you would agree with just by eyeballing it, right? I mean, they probably tried 3 and they found out, no, we hardly ever get an outlier. And I know that guy's too big. He should be an outlier, right? And sometimes they would say, oh, well, let's just do 0.5 IQR. In which case, hey, half my data set looks like an outlier now. That's not sense either. So they kind of tweaked it, and I'm making this up, but probably something like that. They settled on 1.5, and it's a kind of standard acceptable value now, where everybody just agrees that that's what you do. And as
Okay.
long as
I just want to make sure I wasn't missing something that you already explained or something like that.
No, it wasn't some special calculation that you use and it keeps changing. It's always 1.5 interquartile ranges in every case. Now, let's nip over to homework. In this one, here's your data set. You would use find the median, Q1, Q2, find the interquartile range, do the box plot. I mean, isn't that basically just a very similar question, right? So none to see. Now, here we have a data set, and we have males and we have females, and create side-by-side box plots for the fastest speed ever driven by them, and then compare the two. Now that's going to be interesting, side by side. I don't know if Salt can do that. If it can, I'll show you how we get around it. So I'm going to hit this one. I'm going to go charts, and I'm going to go box plot, and I'm going to select a variable, and I believe it was sex. And oh dear, I better go back to the question to find out what. Oh, it was highest speed, right? Fastest speed. Okay, there we go. Hey, it does it. Now, what that is a representation on the left-hand side of the fastest speed reported by males in, let's say, a statistics class. You know, they went and said to you, okay, in your life, what's the fastest you've ever driven? And this person here, remarkable, they're still alive, said it was 150 miles an hour. And this person here said it was 60. And you see the little asterisks are outliers. And you see in this case, they've got a couple of outliers on that side. I'm really surprised that one of the women, one of the females, said the fastest they've ever driven is 30 miles an hour. I mean, if they're telling the truth, they must be living a really weird life. I mean, agreed. But yeah, okay, who knows? Maybe she drives one of those tiny little poppity pop things that can only do 25 unless you're going downhill, right? So I guess it's possible. Now, I want you to look at these two side by side. And I'm going to tell you some information that I can glean just by looking at the shapes and the position of these box plots. Let's look at the males. Would you agree that the males in general, not all of them, but in general, tend to have a faster number or a bigger number than the females? Now, what tells me that? Well, would you agree that the male median was 110 and the female median was only 89, right? So that's a pretty big indication, isn't it? Now, were there some women who did it? Well, look at that woman up there. She's a speedster. She did 130, right? And look at that guy down there. He's what, 55, right? So there are exceptions to everything. We're talking generalizations, right? In general, men tend to go faster than women, which probably explains, although I'm not sure that's true, if you're a guy and you're 25 and you're a girl and you're 25 and you go for insurance, will the guy end up getting a higher insurance than the girl? I'm assuming yes. Do you know if you're 18-year-old and you try and get insurance and you're 29-year-old and you try and get insurance, doesn't your insurance cost more? Now, you might think they're just picking on you because you're young. Do you know the reason they do that? Young people get into accidents a lot more than 27-year-olds do. So the insurance company increases the premium to cover the risk, right? So if they find that men go faster than women and you're an insurance company, would you agree that going fast tends to lead to more serious accidents when you have them? You might have the same number of accidents, but your car's a total wreck and hers is a fender bender, right? And that's a big difference in cost. So I can imagine this data being interesting for that reason. Now, the next and last summary I'm going to make is, if you look at the width, how long this middle box is, that represents the middle 50%, right? The typical group in the middle. And for guys, it's from what, 95 to 120. That's a 25 mile per hour spread. Do you notice that that same box in the female side is only 15 miles, right? What that tells me is that aren't the males much more variable in their speed, right? There's a lot of variation in how fast they go. And aren't women much more tight, more consistent? And so all of those features, those pictures tell me an awful lot about what's going on. And let's see if I can get back to the question, right? So if you look at the 5-figure summaries, would you agree it's much harder to make all those decisions that we talked about, who goes faster, whose varies more, who's an extreme, and so on, right? And you can answer those questions in the usual way. Now, let's move away from box plots just for a moment and look at a different way to visualize data. In this one, students in a stats class were asked about how many minutes do you typically exercise in a week? And this is what the self-identified female said, and this is what the self-identified male said. And we are going to compare the men using a dot plot. So women to men dot plot. So I'm going to go use salt, go into charts, and hit what they're talking about, dox plot, and select variable, self-identified men. There you go. And can I add women to this? Self-identified men. Okay, it looks like I can't do them both at the same time, but I could do one chart, then I could do the second, right? So I should be able to compare the two. And let's just zoom back to the question, right? Now, when it asks you to determine the median response time, you won't get that from the dot plot. Won't you have to go back here and get the median like this? For the women, it's 195, and for the men, it's 190, right? So they may ask you a question that you have to go back into salt and go to a different place. So when you're looking for 5-figure summaries, means, modes, medians, all that good stuff, descriptive. If you're looking for drawing pictures, charts, diagrams, use that one. So that's where you get the numbers from. That's where you get the pictures from, right? And I'm going to close a lot of these windows off because I've got so many open now. And there we go. Question 11 is your basic 5-figure summary. Nothing to see here. Question 12 is 2 different groups, 2 separate 5-figure summaries. Right? Now, this one does not have a salt button. Do you notice that? Does not have a salt button. And doesn't that mean you have to go to plan B and use your TI-84 to get all the numbers? Right. So you would go in and you do group 1, 5-figure summary, write your answers here, rub out that data, and then do group 2, 5-figure summary, put it here, and then draw your own pictures on pieces of paper. Oh, isn't there a possibility there might be an outlier? So check for outliers as well. And then one of these pictures is going to be the right one. I have no idea what it is, so let's pretend it was that one, right? And that's the picture that you've got that looks closest to them is the one that you do. On the other hand, do you see that you've now got a salt button with a big set of data? Right. Now I'm going to talk a little bit, yeah, I've got time, a little bit about some other things that we haven't really focused on since yesterday to do with the 5-figure summary, and in particular, the box plot and what it tells us. So I want you to imagine that I've got a box plot and we won't have anything weird going on, so there won't be any outliers. And here's the scale that we're using. And so I want you to pretend that that number is 10, that's 15, that's 23, that's 33, and that's 60, right? Can you see your 5-figure summary? Now, if I went and said to you questions like, what percentage of, let's say these are ages. So what percentage of ages are between, and let's pick 15-year-olds to 33-year-olds. Now, the way a 5-figure summary splits your data into 4 chunks. Each chunk contains 25% of all the people, right? So if I said to you, what percentage are between 15 and 30, wouldn't I be talking about that bunch? And how many as a percentage would that represent?
50?
50, right? 2 lots of 25. If I went and said to you, what age would you need to be in the top or the oldest 25%? Well, wouldn't that be from the 33s to the 60s? Wouldn't that be the top 25%, for instance?
Yes, sir.
That makes sense? Right. So you get questions like that where you need this with the idea that each section is 25% of all the people. And you can use it to get what percentage of people are from 10 to 23 years old. Answer 50%. What percentage are 23 to 33? 25%. Right? What percentage are in the top 25%, bottom 25? All those kinds of questions. Okay, got nods. I like nods. So let's look further. So here are, actually, that's pretty much the same question as 13. So we'll just let that slide. Mrs. Biggs needs to lose weight. Her doctor put on her a 1,500, oh, the poor woman, 1,500 calorie a day diet. He tells her that she needs to stay below 1,500 calories at least 75% of the time. Okay, so she can have a cheat day. And she needs to keep her mean, that's her average intake, below 1,500 calories over the next 15 days. And these are the numbers that she came up with, right? So we are going to look at this data set and answer various questions, but not the more straightforward ones. They're going to phrase them in different ways. So this is going to be our last question for today. In what term, for the value that cuts off 75% of the data set? Now, if you remember 1 quarter, 2 quarters, 3 quarters, 4 quarters. So if you're talking about what term, what number, or what term, I guess they're using, cuts off the lower 75, that would be the upper quarter. Because if you're at the 3/4 mark, wouldn't the rest of them be to the left of that? Now, calculate the upper quartile. We can do that. Won't that be Q3? And we'll get it. Right? I'm making no attempt to do the right answer. Can we pretend that it was 1450, just for example, right? It then goes on and says, calculate the mean number of calories. Right, now, if you add up all those numbers and divide it by 15, won't you get the mean? Right. Now, all of those things that I've just talked about, including this made up one, can be done by hitting the salt button. So let's do it now so I can get exact values. And for some reason, it went over there. Are you now looking at the salt, the blue guy? Well, I have to go out and in, or can you see it? I can see nods, okay.
Yes, sir.
Now, if you hit descriptive statistics, I want the mean, so I'll keep in that one. And I want the 5-figure summary, even if I don't use all of them. So here are the guys that are left, right? So the mean, oh God, I think she blew her diet, didn't she? Right, remember she had to keep to 1,500. I'm pretty sure that's not going to be the case, so I'll copy that one in and return here. And that goes. Now, the upper quartile, which we already figured out was Q3, is, Interesting. I may have to change my mind here. According to the instructions that she was given by her doctor, didn't she need to be inside the 1500 calorie mark at least 75% of the time? Well, isn't Q3 less than 1500? So technically, didn't she stick to that part of the rule? What probably happened is, oh yeah, I can see it. Can you see that she had two really, really bad cheat days? And isn't that probably the reason why the average blew the 1500?
Well, didn't she have 3 though? Because it says 5,435 right there.
Oh God!
So she had like 3 bad cheat days.
She had bad. Yeah, you can only cheat so many times before it's not really cheating anymore. It's I've broke my diet, right? So she could go to her doctor and hand on her heart, couldn't she say, I stuck to your rule that 75% of the time my intake was 1500 calories or less. And it was, right? It was 1495. And he would say, but you've just put on 5 pounds. Oh, well, that might have been because of my 3 bad cheat days. So you might want to, if you were the doctor, qualify the instructions and say, and the average should be less than, pick a number, right? And that is all we have time for today. So the last thing you're going to do is put your name down, your last name for attendance, and I will see you tomorrow. Okay, guys? So as soon as you've done that, bye-bye.
Thank you.
You're welcome. Hey, we learned some good stuff today, like how to cheat on your diet.
So I got one final question for you.
Yes, James.
I know this is done in a prior math class. I just haven't taken math in a while.
Okay.
When it says run the round the number to the nearest, I understand that part. What is integer?
Integer is whole number.
Oh, whole number. Okay.
Right. So if it was 14.8, you would call it 15. If it was 199.7, you'd call it 200.
Okay.
So
Thank
integer is like a whole number.
Yeah. Thank you, sir.
Okay. And I guess it's bye-bye from you once you figure out how to close it off.
Yeah. I'm sorry. I'm still working on computers. All right, sir. You have a good day now. I think I got it.
Okay. You have a good day too.
All right. Bye-bye.
Bye-bye. Okay. Any other questions before I go? Madeline, you got a question? Then I am out of here. Okay. Bye-bye, everyone. You have a good day too.